Right now, as you sit there watching this, you are moving, not a little, not slowly. You're spinning through space at over 1,000 miles per hour. That's faster than a commercial jet, faster than a bullet fired from a rifle, and you feel absolutely nothing. No wind in your hair. No pressure on your body, no sense of motion at all. So how is that possible? Let's talk numbers first, because they're honestly hard to believe. Earth completes one full rotation every 24 hours. If you're standing at the equator, that means you're being carried around the planet's axis at roughly 1,040 miles per hour. Depending on where you live, your body is moving faster than most airplanes cruise at, and that's just the spin. Earth is also racing around the sun at around 67,000 miles per hour. The entire solar system is drifting through the Milky Way at nearly 500,000 miles per hour, and the Milky Way itself is hurtling through the universe even faster than that. So really, you have never once in your life been still, not for a single second, yet you've never felt any of it. And that's not because something's wrong with your body. It comes down to how your senses actually work. You don't feel steady motion. You mostly feel changes in motion. Think about the last time you flew on a plane. Once it levels off at cruising altitude, you can barely tell you're moving. You can pour a drink, walk to the bathroom, even balance a coin on its edge on your tray table. Aside from small bumps and vibrations, your body just stops noticing the motion, even though you're screaming through the sky at 500 miles per hour. But the moment that plane hits turbulence or drops suddenly or banks hard to one side, you feel it instantly. Your stomach lurches. Your body tenses up, you grip the armrest. The difference isn't speed, it's a sudden change in speed or direction. Your inner ear, specifically something called the vestibular system, is built to catch exactly that. It's got tiny fluid-filled canals lined with hair cells. When your head speeds up, slows down, or turns sharply, that fluid shifts and bends those hairs, and your brain reads it as movement. But if the motion stays smooth and constant, the fluid settles down and your brain gets no signal at all. And Earth's spin is about as smooth as motion gets. Technically, it's not completely still in the physics sense. Because you're moving in a circle, your direction is constantly changing, even if your speed isn't, and that counts as a kind of acceleration, called centripetal acceleration. So Earth's rotation does produce some acceleration. It's just tiny. At the equator, it works out to around 0.3% of the pull of gravity. Gravity is already yanking you downward with a steady, powerful force every second of your life, so that tiny extra pull from the spin just gets buried underneath it. It's like trying to hear a whisper next to a shout that never stops. And since that whisper has been there since before you were born, your body's never had a quiet moment to compare it to. This is basically Newton's first law in action. Without something to interrupt it, motion just keeps going, unnoticed. And this actually answers something a lot of people wonder about too. If Earth's spinning that fast, why doesn't everything just fly off into space? Simple answer: gravity. Even at the equator where the spin is strongest, it's nowhere near strong enough to beat gravity's pull. There's another piece to this puzzle, and it matters just as much. It's called a reference frame. Picture yourself sitting in a car, windows up, curtains closed, no way to see outside. If that car's cruising at a smooth 60 miles per hour down a straight highway, you'd have no clue you were moving. You'd feel exactly the same as if it were parked in a garage. That's because everything inside the car, including you, is moving at the same speed in the same direction together. Nothing's shifting relative to anything else. You're not being left behind or slammed into anything. You and the car are basically one system, moving through space as a unit. Earth works the exact same way, just on a much bigger scale. You, the ground, the air, the buildings, the oceans, all of it is spinning together at the same rate in the same direction. Even the atmosphere spins along with the surface, which is why there isn't some constant 1,000-mile-per-hour wind ripping across everything. You're moving right along with the planet, perfectly in sync. That's also why, if you jump straight up, you land in the exact same spot. You might think Earth should spin out from under you during that half second in the air, but it doesn't work that way because when you jumped, your body was already moving at the same rotational speed as the ground. That momentum doesn't disappear the second your feet leave the floor, you carry it with you. And this only works because Earth's been spinning at this same steady rate for billions of years, not just since yesterday. If it somehow stopped spinning suddenly while the atmosphere kept moving, things would get ugly fast. Winds faster than the speed of sound tearing across the planet, oceans surging over entire continents. The only reason none of that's happening is because everything around you has been moving together in sync for way longer than humans have even existed. So here's a fair question. If the spin is truly impossible to feel, how do we even know Earth is rotating at all? How did anyone figure this out before satellites and space travel? Turns out it took some pretty clever thinking. For most of human history, the idea that Earth was spinning beneath our feet sounded ridiculous. If the ground was really moving that fast, surely we'd be swept away or thrown into the sky or at least feel some kind of massive wind. Ancient philosophers used exactly that logic to argue Earth had to be stationary. It just seemed like common sense. It took centuries of careful observation and a fair amount of nerve to prove that wrong. One of the best proofs came in 1851 from a French physicist named Léon Foucault. He built a simple device, a heavy pendulum hanging from a long wire, swinging back and forth in a straight line. Over several hours, the direction of its swing seemed to slowly rotate. But the pendulum wasn't actually changing direction at all. The plane of its swing stayed exactly where it started. What was actually rotating was the floor beneath it, the building, the city, the whole planet. Foucault had basically found a way to make Earth's invisible spin visible, using nothing but gravity and a swinging weight. Versions of his pendulum are still swinging today in science museums around the world, quietly proving, second by second, that the ground under our feet is turning. What made it so convincing at the time was how simple it was. No telescopes, no rockets, no complicated instruments, just a weight on a wire left alone to do what physics said it should do. Anyone could walk in, watch it for an hour, and see the proof drawing itself across the floor. There's one more clue, and you can actually see this one for yourself with zero equipment. It's called the Coriolis Effect, and it shapes something you've watched 1,000 times, the weather. Because Earth's rotating beneath moving air and water, they don't travel in straight lines over long distances, they curve. In the northern hemisphere, moving air bends to the right. In the southern hemisphere, it bends left. That's why hurricanes up north spin counterclockwise and cyclones down south spin clockwise. It's why long-range missile calculations have to account for the planet's rotation. It's why ocean currents loop across entire oceans in these massive, predictable patterns. None of that would happen on a stationary Earth. The Coriolis effect is baked into the shape of every storm system on the planet, a permanent signature of a spin we can never actually feel. Pilots and ship navigators have to correct for it too, because over long enough distances, that invisible curve can throw a flight path or a shipping route off by miles if nobody accounts for it. It's a small, constant nudge that shapes everything from a single thunderstorm to entire ocean currents circling the globe. So put it all together and here's what you get. Your body is wired to catch changes in motion, not a smooth, steady spin that never lets up. The tiny bit of acceleration Earth's rotation does create is so small next to gravity, it just gets swallowed up. You, the ground, the air, everything around you all moving together as one system, which wipes out any sense that you're moving at all. And the only reason we even know this is happening is because a handful of curious people built pendulums, watched storms bend across oceans, and refused to accept that not feeling something meant it wasn't real. There's something kind of humbling about that. Every single day, you're living proof of one of physics' quietest, most elegant secrets. A planet spinning at over 1,000 miles an hour, carrying you, your home, your whole life through space in complete silence. No wind, no sound, no sensation at all. The ground beneath your feet has never once stopped moving. You just never had a reason to notice.